Hey, what is up guys? We are back with another Leetcode problem. Today we're going to be doing number 1590, make sum divisible by p. Given an array of positive integers and nums, remove the small subarray, possibly empty, such that the sum of the remaining elements is divisible by p. It is not allowed to remove the whole array. Return the length of the smallest subarray that you need to remove, or -1 if it's impossible. A subarray is defined as a contiguous block of elements in the array. Okay, so for example, we have this array, nums 3, 1, 4, 2, p is 6. Okay, and we need to make the sum of these numbers divisible by 6. And the way we do that is we need to remove some kind of subarray. In this case, we'll remove the subarray here, the subarray 4, the subarray, and then the sum will be 6. So we'll get 3 plus 1, which is 4, and plus 2, which is 6, and that 6 is divisible by p, which is 6. So 6 is divisible by 6, and then we know that's an answer. And how many elements did we have to remove? What was the size of the subarray that removed basically? Well, it was a size 1. It was just this number 4, and so therefore we'll return the answer number 4. Okay, so how are we going to approach this problem? Let's think about it. First thing first, once again, I think I mentioned this in a previous video. I'll link the video below where I talked about prefix sum. Whenever you have some kind of array of subarrays, where you're looking for subarrays, or you're looking for the sum of some subarrays, right? You're dealing with arrays and sums. Usually, not all the time, not even most of the time, but I guess a lot of times, it'll involve some sort of prefix sum variation. Okay, so some sort of a prefix sum variation. Okay, so now let's think about it. We have this array nums, and we know we need to remove some subarray such that the new sum will be divisible by p. Okay, so first things first, let's get the sum of the entire subarray, this entire array we're given. And so the sum of this array nums is what? It's 10, right? And now I need to remove some sort of elements, right? Some subarray such that is divisible by 6. And so the only number would be it's 6 in this case, okay? So then that means I would need to remove what? 4. That would give me 6. To explain this better, let's use a better example, which is 100. Okay, let's say the sum of our array nums, right? Sum of nums was 100. Okay, let's just, for example, I say sum of the nums was 100. So we have 100, and we'll say p is still 6. Now we need to remove some sort of subarray such that the new number would be divisible by 6. So that means I need to remove some number right over here, which is x, such that then this new number modulo 6 would be equal to 0, right? Now, how do I figure out what this number x needs to be? Okay, let's think of it. Let's just use some examples. I know that it needs to be a multiple of 6, and so how will I achieve that? Well, I know that 100 divided by 6, or modulo 6, is what? 4, right? That's going to be the remainder when we divide 100 by 6, 4. And so then I know that if I move 4 from 100, I'll end up with 96. And I know 96 modulo 6 is equal to 0, and that would be 96 divided by 6, that's 16, right? I'll end up with 16. But that's not the only number. I can now remove this number 4 plus any multiple of 6. For example, now let's say I moved 100 minus 6 plus 4, which is 10. What would that give me? That would give me what? 10, right? 100 minus 10, 90. And 90 modulo 6 is what? 15. Then I keep multiplying this, so I'll get 12. And I'll do 90, or 100 minus 90, what is that? 84. 84 modulo 6 should give me 14. 84 divided by 6, sorry. 14, yeah, 84 divided, sorry, this is divided. Divided. And the modulo will basically be 0. Okay, so now that's that. So now I know x could be any number, which is 6 times any integer. Any integer, we'll just say n, plus 4. Right? This could be our possible sum of this subarray, right? In this case, it's 4. In any other case, so this would be the sum of a subarray. This is what x would be. And so now I know I need to look for a subarray that sums up to x. And we know that whenever we're looking for a subarray that sums up to a certain number, we'll use prefix sum. And I'll link some videos below that explain prefix sum a little bit, or you could just do some YouTube Googling and figure out what prefix sum is all about. Okay, so now my problem is reduced to finding a number such that this condition is fulfilled. And from there, it becomes very, very simple. And the rest of this explanation will be as I walk you through the code. So I'll be right back with that in 1 second. Okay, so here we have Rock's answer and his explanation. Once again, yes, I'm taking someone else's explanation because it helped me understand the solution a little better. And one of these comments too as well helped me really, really understand the solution. But basically, this is how it's going to work. And let's just take this right now, and then we'll do this. We'll put this in our current problem, and then we'll work from there. I don't think I grabbed the end, so. All right. So how is this going to work? Well, we have this remainder, and we have the prefix sum currently, right? And we have n is the length of the array, and minimum length is n. Anyways, so now we're going to go through all the numbers, right? And we're going to calculate the remainder. What that was basically doing was what we did right here. We calculated the sum, and we divided it by p, and we kept getting the remainder. And so that's what this is doing. In this case, instead of summing it all at once and then dividing it by p, because the sum of the numbers could go over the size of int, we're just dividing it by p every single time. Right? So we keep dividing by p, and then we'll end up with the remainder. So this remainder in this example will get 4. Right? We'll end up with the remainder of 4. Right? If the remainder is 0, then we return 0, meaning we didn't have to remove anything to get a number that to get a sum that is divisible by p, exactly divisible by p. From there, right? From there, we'll create a new hash map, and this is our prefix sum hash map. And so what this hash map is going to store is just like ignore all this modulo stuff for now, right? Just like our normal prefix sum problems, we're going to look for certain sums, and we're going to keep track of their indices. So for example, we're going to add up the sums of an array, in this example 3, 1, 4, 2, and we're going to keep track of its indices. So 3 will be 3, we'll bring up our prefix sum with 4, 4 is 8, 8 plus 2 is 10, right? And at each of these steps, we're going to store in our hash map the index of this current sum. So 3 will be stored at 0, 4 at 1, 8 at 2, and 10 at 3, right? Ignore the modulo stuff right now. Don't worry about that. And then what we do with prefix sum is then we keep going through it. And so now we're looking for a number such that this condition is fulfilled, right? And so in a normal prefix sum, we'd go through it, and then we're looking for the number, let's say 4 or 96, right? And then we check our hash map to see if that key is included or not, and if it is, then we return the answer. I don't want to explain it right now. I know I'm just rambling on. This explanation probably isn't making sense. That's why if you don't understand prefix sum, you have to watch another video on it, because I don't want this video to be all about prefix sum. And I explained it a little bit in detail in one of my previous problems. But once again, just do some Googling, some YouTube. But anyway, so now that you know all about the normal prefix sum, this is a little different. Why? Because the numbers can overflow, right? It won't fit in the size of int. So instead of calculating the prefix sum like this, at each step, we also want to mod it by p. At each step, we also want to mod the number by p. Okay? And then once again, usually when we find the key, we just do the prefix sum minus the number that we're looking for, and that's it. But in this case, we have some super complex thing right here. This line tends to get very confusing. We have prefix sum minus the remainder plus p, and then modulo p again, and it gets really confusing because usually we just do a prefix sum minus our target, and then we look for that key in our hash map, and then we grab the index, and then we can find the range that way. So what is this line doing? What is it all about? Okay. So to explain this line, I'm going to go back to discussions, and I'm going to use someone else's explanation, because once again, I want to give credit, and I want to mention that, you know, it helped me. Let me give this guy a plus. So he explains that there are two parts to recognize this question after a long time, and So after getting sum of the entire array modulo p, this is the new target to find in the subarray, meaning the remainder. The remainder is the new target, as we explained and discussed. So now we can think of the question, the regular subarray target finding problem. It's not really a regular subarray target finding problem because, as we explained, the numbers can overflow. So it's just a subarray target finding problem. Then the next step, the hardest part, is finding out the key calculation, which is the pre-sum minus the remainder plus p, which is this line right over here, right? This key calculation right over here that we talked about. So he explains, let's say p is 2,000, our target is 1,000, right? This is the number that we're looking for, and our current sum so far is up to 600. The current sum could have been 2,600, 4,600, 6,600, right? 8,600. Why? Because we're getting the modulo of p each time. We're dividing by p each time, right? And we're keeping the track of the remainder. So we know that it's 600, and it's never going to go above 2,000 because every time it goes above 2,000, we bring it back down to under 2,000, right? We keep getting the mod. So this current sum could have been either of these numbers. So now when we find our key, it gets a little confusing. So the first thing we need to do is we need to add back that 2,000, okay? The order here, I guess, kind of confused me for a while, right? Because I couldn't get this answer probably. I got the n squared solution. I was getting TLE. Then I had to, whatever. I had to go through the discussion board. I couldn't figure out the thing. I knew it involved some kind of prefix sum, but this key part right over here, this part really kind of just had me lost. And even when I looked at the solution, I was a little lost. But anyways, so the first thing we need to do is we need to add back this p, okay? So we need to do 600, the sum, plus the 2,000. So we get 2,600. And then from there, that 2,600, then we need to subtract it from the target, and modulo by p, of course, since we're modulo by p each time. And then we look for that in the hash map. So what we'll do is we'll do 600 plus 2,000, which will get us 2,600, and we're looking for we're looking for a subarray of 1,000, right? Of size of 1,000. So what we'll do now is like we know when we have a target, we have to subtract from there. So we do 2,600 minus 1,000, which will give us 1,600 right over here. So we do 600 plus 2,000. Switching this order around, it kind of helps a little more. So 600 plus 2,000 will give us 2,600. And then we need to subtract the target, as usual in a regular prefix sum approach. So we'll subtract the target right here, which is 1,000. And then we'll end up with 1,600. And then we need to find something at some point where we saw a value in the sum previously in the prefix map of 1,600. So that's where we'll check over here. We'll look for the key, right, in our prefix sum to index hash map. And if it's there, then we have a solution. We have a solution, but we want the minimum solution, right? We want the minimum solution. So we'll either use the previous solution that we found already, or we use I minus the index of the sum of that key of 1,600, where we got 1,600 previously, right? And this will give us the length, right? This will give us the length of that subarray, and this is the previous length of our previous answer that we previously found. And then we just keep track of whichever one is the minimum, and we set that the minimum, and then we put our current prefix sum back in the solution, and that's basically that. It's literally just a regular prefix sum approach, and like Xiao explained his answer, these are the two really tricky parts. The first part is a little easy to recognize, right? Maybe hard for some, it's okay, it's fine. The second part, finding this key calculation, gets a little confusing, like when to add p back, do you need to modulo p again, and so on and so forth. Main thing is realizing you need to add the p back. And then once again, if the minimum length is, back to the problem, if the minimum length is equal to n, right, meaning we couldn't remove, we had to remove the entire thing to get to 0, which would be modulo, so on and so forth. But anyways, then we return -1, else we just return the minimum length. That's basically the solution. I feel like this explanation kind of sucked, but I don't know. Anyways, look through this problem, look through some of the other guys' explanations. It'll help. It helps a lot. I think I did an okay job. So that's that. Please leave a like, subscribe, comment, or leave a dislike if you didn't enjoy it. It's fine. And comment how I can improve these. And I'll see you guys for the next problem.